Okay, so picking up where we were in class, we know with this spherical balloon we have a volume formula here, and they told us that the volume is equal to 972 pi meters cubed. They told us that the balloon is being inflated, so that is our dV/dt right here. When we set our volume equal to a volume formula, we're able to then solve for r. So we set 972 pi is equal to 4/3 pi r cubed. The pi's will cancel each other out. Multiply by the reciprocal, and you get 729 is equal to r to the third. So the cube root of that means r is equal to 9. When we have our, that was Kevin, if you heard that. When we take our volume formula and we differentiate it, or I take the derivative of it, we get dV/dt is equal to 4 pi r squared dr dt. So now we're going to plug in the values that we know. dV/dt is equal to 10, r is equal to 9, so we get times 81, and we're going to solve that for dr dt. So when you divide by 4 times 81 pi, you get 10 divided by 324 pi, and that is dr dt. Now we're going to need these values when we do our surface area. Okay, so we have our surface area right here of 4 pi r squared. If you need that tomorrow, I'll give it to you. We're going to take the derivative of that, so we have ds dt is equal to 8 pi r dr dt. So we'll plug in our values. We have 8 pi, r we know is 9, and dr dt we have is 10 divided by 324 pi. And that is ds dt. The pi's will cancel each other out. So 9 goes into 324 36 times. So we're left with ds dt is equal to 80 divided by 36. You can continue to reduce that, and that's going to be meters per second. Alrighty? Good. That's the end of question number 1, or that we didn't finish in class. Okay, for number 7, it says a 10-foot ladder. So we have our 10-foot ladder leaning against the wall. The foot of the ladder is sliding away at the wall at a rate of 2 feet per second. So that will be this side that will be moving away. They want to know how fast the top of the ladder is coming down when the ladder is 6 feet from the wall. Well, if the ladder is 6 feet from the wall, then we know that the height of the ladder at the instance that we're looking at is 8. And since we're using Pythagorean theorem, we're going to take the Pythagorean theorem and differentiate it. Now, the thing that's not changing in the Pythagorean theorem is the c term. So we have 2a dA dt plus 2b dB dt. And since the c term, the ladder is consistent, that has no change. And therefore, that value will be 0. Plugging in the values we know a is 8. The dA dt is what we're looking to find. We know the b value is 6. And we know it's moving away from the wall at 2 feet per second. And that's equal to 0. So, 2 times 2 times 6 is 24, divided by 2 is 12, divided by 8. So we have dA dt is equal to negative 12 divided by 8. And again, we can reduce that as well to get negative 4, negative 3 over 2. Okay, and that will be feet per second as well. Okay, so we have a can that's being filled with water at a rate of 50 centimeters cubed per minute. That means that is going to represent our dV/dt because the water is being filled into the can. The radius of the can is 10 centimeters. How fast does the height of the water of the can rise? So we're going to make an assumption that radius and height are equal, just to make our life slightly easier. So knowing that, when we look at the volume of a can, we have volume is equal to pi r squared height. So since the radius and the height are equal, that gives us pi h to the third. When we differentiate that, we get dv dt is equal to 3 pi h squared dh dt. Now since the radius and the height are equal, if r is equal to 10, that means the h has to equal 10. So we're going to plug in these numbers. So we have 50 is equal to 3 times pi times 10 squared times dh dt, and that's what we want to find. So 50 divided by 300 pi, is equal to dh dt. And then you can reduce that to be 1 over 6 pi. Alright, I hope this helps. Good luck.